Typed instances provide the same capabilities as named clients without the need to use strings as keys. Let's add a new class to our movies.client project. And let's name it Movies API Client. In this class, we inject an HTTP client with constructor injection, and we make that one publicly available as a property with just a getter. That's it for the Movies API client for now. Then we want to register this client on the services collection. So let's switch to the program class, and let's call into services.addHTTP client, passing through the type Movies API client. This registers our Movies API client with a transient scope. The factory will automatically create an instance of HTTP client with whichever configuration we input when an instance of Movies API client is requested from the DI system. And just as before, we can add some default configuration. For that, we pass through an action to configure the client. We set the base address and a timeout value. Configuring handlers and the primary handler can be done by chaining methods, just as we learned previously. That's already it for registration and configuration. Let's open the HTTP client factory samples class again. We can now inject a Movies API client with constructor injection. There we go. It's this instance we can now use to access our API. And let's add a new method for that. We'll name it getMovies with typed HTTP client async. So we new up an HTTP request message and set the accept header just like we did before. The one thing that's different here is that instead of creating a client through the factory, we now use the exposed client property from our Movies API client instance. Alright, let's put a breakpoint here. And let's make sure we call this method. And let's give this a try. And there we go. This works as expected. There's more we can do. We can scope the configuration to our type instead of when we register it on the services collection. Let's learn how to do that. We're looking at our Movies API client. As the DI system injects an HTTP client instance, we can move the default configuration to the constructor, so it is nicely contained within this class. So, we set the base address and the timeout value. Important to remember is that if you've configured a custom client handler, you do not want to override that here. If you do that, the handler won't be coming from the pool anymore, and you don't want that because of all the reasons we looked into at the beginning of this module. Okay, let's open the program class and let's change the configuration. I'll just comment it out so you still have it for reference. And let's give this a try. Normally, our previously created request should still work. And there we go, that is indeed the case. Now, this Movies API client class looks quite empty, doesn't it? Let's see what else we can do. As we now have a typed client, we can move some implementation details to it. It's a Movies API client, intended to be used for integrating with our Movies API. From that we can offload the implementation of, for example, getting a list of movies to this class. Like that, the Movies API client contains the methods to interact with the Movies API in a reusable manner. So let's add a method, getMoviesAsync. I do need to import the namespace that contains the model classes, so let's add a using statement to movies.client.models. And it resolves again. So what do we want to do here? Well, we want to create a new request message and use HTTP client to send the request to our API. Not much new to see here. If the response was successful, we parse it and deserialize it into a list of movies. This is mostly a copy-paste of our getMovies with typed HTTP client async method from a previous demo. One more thing I have to do here is inject the JSON serializer options wrapper, so we have access to that. We're using system.text.json, so I also need a using statement to system.text.json here. And that should take care of this. If deserialization fails, null will be returned, which is why we explicitly mark the potential return value as nullable with the question mark. Alright, this should work. However, if you're gonna go this route, I would suggest not exposing the client property anymore. It's not needed anymore, as consuming classes will now use one of the methods like getMoviesAsync, which we define on the Movies API client. They have no need anymore to directly access the HTTP client contained within the Movies API client class. So let's change this to a private field. There we go. A bit of refactoring quickly took care of that. On to our HTTP client factory samples class. First of all, let's comment out this old getMoviesWithTyped HTTP client async method. It won't work anymore because it relies on the client property of the Movies API client being available, and we just made that private. Instead of having to write all this code we just commented out to get a list of movies, we can now more concisely write it as such. We simply await a call into getMoviesAsync on our Movies API client. To test, let's set a breakpoint here, and let's make sure we run this. And let's build and run. That seems to have worked. And indeed, here's our list of movies. So there we go. We now have a nice piece of contained functionality inside of our Movies API client, which allows it to be reused easily. To round things up, named and typed instances can be combined. You can name a specific typed instance if you want to when registering it, just as we previously did. But if you do that, I would suggest to keep the configuration out of the typed client, as it may depend on the named version of the typed client you're using. And with that, we learned a lot about the HTTP client factory. Time for the module summary. When we dispose of HTTP client, the underlying sockets HTTP handler is disposed of as well. This results in connections having to be closed and reopened for additional requests, which can eventually lead to no more sockets being available to open these new connections. That results in a bad experience for the user of your application. On the other hand, if we keep on reusing the instance, the connection is reused as well. And that means that DNS changes aren't honored, which can result in our application trying to call an API via a URI that no longer matches the correct server. To solve these issues, Microsoft introduced the HTTP Client Factory. It's responsible for creating and managing instances of HTTP client and related handlers, and it mitigates both issues. Currently, it's best practice to use this factory instead of creating instances ourselves. As we've seen in the demos, it supports direct instantiation, named instances, and typed instances. There is no best option here. It really depends on your requirements and/or architecture. With what you've learned up until now, you should be able to write basic integration code with correct HTTP client instance management. But we're definitely not yet at the best practice approach. In the next module, we'll dive into improving performance and memory use with streams. We want to keep the memory footprint of our application as low as possible and the performance high. Streams help with that. In this module, we will learn how. We will start by learning what streams enable, in other words, the advantages of working with streams. Then we will learn how we can use that knowledge with HTTP client. In the demos, we will learn how to read data using streams, how to send data using streams, and we will test the potential performance improvements. Let's dive in by learning about the advantages of using streams. So, what is a stream? It's an abstraction of a sequence of bytes, such as a file, an input-output device, or network traffic, The stream class and its derived classes provide a generic view of these different types of input and output. And like that, it isolates us from the specific details of the operating system and the underlying devices. Important is that we can read from and write to such a stream, depending on the type, when dealing with network traffic and with in-memory objects. Like that, we don't have to use temporary in-between variables that increase memory usage and can hurt performance. So these are the main reasons for working with streams. But before we continue, let me clear up a bit of potential confusing surrounding the word stream. The stream I'm talking about at this moment, well, that is that abstraction provided by us via the stream class. It's a coding concept that abstracts a sequence of bytes. This can be used anywhere where you're writing code. So, at level of the client, at level of the API, or anything in between. Important is that these are separate from each other. An API doesn't need to use streams to allow a client to use it and benefit from it, and vice versa for that matter. Everything you will learn in this module can be used regardless of how the API is coded. So that's the code concept. But a stream also exists as a data transfer concept, and that's where the confusion sometimes stems from. The fact that we're working over HTTP inherently means that the bytes we get from the API or that are sent to it are, well, streaming over the wire. HTTP runs on top of TCP, and TCP packages are 64 kilobytes maximum in size, but often much smaller. So, whether you're watching a movie, surfing to a site, or interacting with an API over HTTP, the data itself comes in streaming, in order, package by package. So, a stream as a data concept means that data is streaming over the wire. But that's not the end of the story. That data that's streaming over the wire can be pushed by the API in one go, or it can asynchronously stream from that API. And that brings us to the last part, streaming support for APIs. If your API supports asynchronous streaming, it means that the API itself can send parts of the response over the wire one by one as a continuous flow, for example, coming directly from the underlying database. So, instead of returning one piece of JSON with a bunch of movies in it, when getting the movies, it would return these movies one by one. So, movie by movie. That, again, has nothing to do with supporting streams at level of the client. In fact, in the next module we will dive into dealing with an API that supports this type of streaming. You will notice it's a completely different thing from what we will learn in this module. So there we go. I hope that already clears up some potential confusion. Now it's time to learn how to use streams when getting data.